Okay, Math140G fans. What we have here is the homework question in the rates of change and derivatives homework, where I ask you to perform some backwards, forwards, and center differencing analyses on this particular function using a spreadsheet. So I'm going to show you how to set this up and get the backwards, forwards, and center differences computed, and then the rest of the stuff ultimately falls into place once you have that set. So what I have here is I have I opened the template that I posted on Angel in Microsoft Excel. And if we don't have Excel, if you're using something different or you don't have access to this on your personal computer, I show you some other options. You should know that all student computers at Penn State have Microsoft Office, so you should be able to get this open one way or the other. What I'm going to do is I'm going to build a function table, x and y. I'm going to use this function because you have a different function in your homework. I'll use this one. It's still a cubic function. It's a polynomial. Like I said, I'm going to build a function table. Let's start with the top value. Here's my domain, -5 to 4. This is my delta t, the increment. So I'm going to simply start and with an equal sign, and let this cell equal the beginning of my domain. The cell after that, I'm going to let this equal the previous cell, but I'm going to add to it delta t, or the increment. And I'm going to make this an absolute reference by pressing the F4 key. You see I toggle the absolute references. This locks the column and or the row as I will propagate the formula down. So you see I have both the column and the row locked. Just the row locked. The column is now locked and back to normal. So I'm just going to lock the row. And I'm going to drag this down. I think I have to go here. So this is the end of my domain to +4, and I have all of my x values in. Now I'm ready to enter my y values. Again, I'm just building a function table. So note that instead of x's, this is my independent variable, which is now expressed in column A. So instead of x's, I'm just going to put in a's. You see this is a3 cubed, which is this cell right here. I'm going to subtract a3 squared and +5 times a3 +5. I think that looks right. Run it. Found an error. I forgot my multiplication sign. Excel will correct that, and I have an expression. Alright. Now I'm going to just drag this down. If I double click this key as my cursor turns to an iron cross, this will propagate the whole way down to the bottom of the column next to it. That was just a double click. Here's my function table. Now I want to do a backwards difference. That means that I'm going to start with this point right here, -4.75, and I'm going to compute an approximate dy dx, delta y divided by delta x, using the point behind it. That's why it's called backwards. So I'm going to state this minus that, there's the backwards part, divided by the change in x. Well, I can just use this value to represent my change in x, and I have to absolute that, and I'll propagate that down. You see that the last value works with the backwards difference, but the first value I can't subtract further backwards. For the forwards difference, it's going to be the opposite. I'm going to start with this particular point, and I'm going to move forwards. So that minus this. divided by my change in x. Because the first value works for the forwards, the last value will not. You see how strange that is? So I delete that. Now the center, I pick points on both sides of the value that I'm going to approximate. So it will look like this. But because I'm skipping over 2, I have to only use, I want to sort of average things together or use 2 increments. So that's going to be divided by 2 increments. You notice I can't use the first value for center differencing, and I'm not going to be able to use the last value. So what I've done is I've set up my backwards, forwards, and center differences. I am going to clean this up a little bit. Do 2 decimal places. Now, for this particular one, the part B, the center difference of the center difference, what I want to do is I want to just perform another center difference using this column. This is conceptually the same as the second derivative approximation. It's how you would continue to do multiple derivatives using real data. So just like I did for my center difference, this minus this divided by 2 of my increments. And again, I can't use my last 2. Just look at the symmetry that's happening here. If I were to keep doing center differences, so, have my table all cleaned up. Here's the plot, what the plot looks like. Blue is the f of x. You see it has 2 bends in it like that. And what I can even do is I can stretch or shrink this axis a little bit. Just so the bends are a little more obvious. I'll do one more. Let's bring that out a little bit. Now, what we have here is the 3 differences. Backwards, forwards, and center differences. They're not all the same. Why? You can see the center difference is always going to be sort of split the difference between the forward and backward. It's always going to be in the middle. As the rate of change slows down, the error becomes less. So there's some other questions that you'll be able to answer by looking at this plot. Feel free to move the plot around to zoom in on the plot so you can see things better by changing your axis values. One part of the homework question asks you to change the increment to 0.1. So I changed the increment to 0.1, but the problem is I don't cover the whole domain now. So let me show you how to fix that quickly. I'm going to drag all these down so it's square. Then I'm going to bring that over, and I'm going to drag them all down. Let's try 100. So 100 was enough. You see, here's the end of my domain right there. So I can just get rid of these. And remember, this is my f of x. This is my backwards. This is my forwards. So I need to get rid of that. this is my center, so I need to get rid of that. And this is my center, so I need to do that. Clean that up. Now we have a better increment, a more resolute increment at 0.1, and you can sort of see what the changes will be. What if I were to make it 0.5? Again, this is a more coarse approximation, and you can see what's happening to the differences between forward, backwards, and center. So this is how you set up the homework problem for number 3. Good luck.